Let x, y, and z be positive real numbers. We are asked to find the maximum value of the expression 6xy minus y to the power of 4 minus 2z squared multiplied by 6yze minus z to the power of 4 minus 2x multiplied by 6ex minus x to the power of 4 minus 2y squared. We let capital J be this entire product. Suppose x equals y equals z. Then the expression becomes j equals 6x squared minus x to the power of 4 minus 2x squared, all cubed. This simplifies to 4x squared minus x to the power of 4, all cubed. Now factor as 4 minus the square of x squared minus 2 raised to the power of 3. This is maximized when x squared equals 2. Therefore, j is less than or equal to 4 cubed, which is 4 cubed, 64. But does this give the actual maximum value of j? Let's confirm by bounding each factor. Let's consider the first term, 6xy minus y to the power of 4 minus 2z squared. What is the upper bound? We want to show that 6xy minus y to the power of 4 minus 2z squared is less than or equal to 4x cubed divided by y times z squared. Rewriting this is equivalent to y to the power of 4 plus 2z squared plus 4x cubed divided by y times z squared is greater than or equal to 6xy. Now apply the AMGM inequality to the three terms, y to the power of 4, 2z squared, and 4x cubed divided by yz squared. By AMGM, the sum is greater than or equal to 3 times the cube root of y to the power of 4 multiplied by 2z squared multiplied by 4x cubed over yz squared. This simplifies to 3 times the cube root of 8x cubed y cubed. Which equals 6xy. Therefore, the inequality is valid, and we conclude 6xy minus y to the power of 4 minus 2z squared is less than or equal to 4x cubed divided by yz squared. We now apply similar bounds to the other two factors. The second factor, 6yz minus z to the power of 4 minus 2x is less than or equal to 4y cubed divided by zx squared. The third factor, 6zx minus x to the power of 4 minus 2y squared is less than or equal to 4z cubed divided by xy squared. So j is less than or equal to the product of 4x cubed over yz squared, 4y cubed over zx squared, and 4z cubed over xy squared. Multiply all three together. Numerator, 4 times 4 times 4 is 64, multiplied by x cubed, y cubed, z cubed. Denominator, yz squared times zx squared times xy squared, which is x cubed, y cubed, z cubed. So the product becomes 64 times x cubed, y cubed, z cubed over x cubed, y cubed, z cubed, which is simply 64. Therefore, j is less than or equal to 64. Now, equality holds in the AMGM inequality if, and only if all three terms are equal. That is, y to the power of 4 equals 2, z squared equals 4, x cubed divided by yz squared, and so on. Solving this system gives x equals y equals z equals square root of 2. Substituting into the original expression confirms j equals 64. Thanks for watching. If you enjoyed this problem and learned something new, don't forget to like, comment, and subscribe. See you in the next video.